So hi children, in this video we are going to discuss about the new concept elementary geometry. Okay, so before going to explain the topic, just in regular day-to-day life, every day in generally we can observe that so many things. No, if you observe a ball while you are playing, you can observe that a ball. Okay, most of you interested to play cricket, right? So while you are playing that cricket, you can observe that ball, bat. So each and everything, not only like that, any other things also having that some shapes, right? So those shapes, some of them having that circle shape, some of them having that square shape, some of them having that triangle shape. So what we will call these all shapes? These all shapes comes under that geometry, right? So in our day-to-day life, every day we can observe that any one of that shape. Okay, if you observe your house, that house is one of the shape. Okay, either that house is consisting of rectangles, squares, triangles, so many shapes, no? So those all shapes comes under that geometry. So before going to draw that any shape, first what we required? Without any place, is it possible to construct any house? Not possible. If you doesn't have that any place on that paper or any surface, is it possible to draw any picture? Not possible, right? So if you want to draw that any picture, then you require that a sufficient place, or at least you have that place. Okay, you have to draw. If you want to draw that any particular figure, then for example you must be need that one of that paper. Okay, so that those all comes under that first thing, plane. If you have that plane surface, then you can draw that any figure, right? So let us see that about plane. So a plane means it is a flat surface which can be extended endlessly in all directions. What is that? A flat surface which can be extended endlessly in all directions. Okay, a flat surface which can be extended endlessly in all directions, then we will call that surface as plane. Let us see that here I taken that this board, this is also one of the surface. If this surface is not there, where I will write? Here one of the surface is there, then only I will write here something. If here this board is not there, then where I will write? So here I taken that this board is one of the example for plane. Okay, if you want to write something, if you want to construct something, mustn't should you need that some place. That place I taken here, either there is a flat surface. On that flat surface only we can draw that, right? So here this flat surface I taken this one example for plane. Okay, let us take that this is one of that example. Okay, here I taken this is one of the plane. I want to extend this plane. Is it possible to extend? Obviously. Okay, we can extend this plane either in any direction, we can extend this one. Okay, that's what I am saying, that a flat surface, a plane must be a flat surface which can be extended endlessly in any direction. Okay, then we will call that one as some plane. So to this plane I am giving the name as E. I am giving the name as E. So I will call this plane as plane E. What I will call? I will call this plane as plane E. Why? Because here I given the name as E to that plane. So I will call that plane as plane E. Okay. So after that plane, now I have here one of the plane. If you want to start that anything, if you want to write anything, first you have to start with that dot. Okay. First, if you keep your pencil or if you keep your pen on that flat surface, the first figure what you have to keep, that is a dot, which is nothing but a point. What is that? That is a point. Okay, by starting whatever it may be you want to draw, first you have to keep some point, then only you can draw that. If you want to draw that any figure, then you have to first you have to keep your pen or keep your pencil on that surface. No, so first which figure you have to keep, that is a dot. So that dot only we will call, in come to that geometry we will call that one as point. Okay, so point is that having that any, I mean this is having any thickness or something, this is not having any size or thickness, whatever it may be. Okay, but it is showing that position. So point means it shows some position, mark that position is called a point. So here I kept one of the point, no? So what are the properties of the point means points should be represented with a capital letter, should be represented with a capital letter. So this one I will call it as point A. I will call that one as point A. Always the points should be represented with capital letters only. Okay, so here I taken one of that point. What is that? This is that point B. Okay, I will call that one as point B, and this is point C. So like that way we can take that so many points now. Okay, so here what are the properties of that points? Point is also having some properties now. What are those? Here points should be represented with a capital letter, denoted by a capital letter. That is the first point. And the second one is that point is not having that thickness, as well as point is not having that any length or breadth. Okay, but it is showing a position. Here I kept a point means here that point is showing that one of the position. Okay, so these are the properties of a point. After that point we have that line segment. Okay, next we have that line segment. So what about that line segment? Previous I taken that one point something, we will give that name as a point A, point B, like that. Here I taken that 2 points on a plane. Okay, so if you taken that any 2 points, here I taken this one as point A and this is point B. Okay, the shortest distance between the 2 points A and B, shortest distance, how we can calculate that? By joining these 2 points we can calculate that. By joining those 2 points we can calculate its shortest distance. Yes or no? So here by joining these 2 points we will get here one of that figure. So we will call this figure as line segment. Okay, that line segment is having that 2 points, no? Here those two I given name as A and B. So we will call this line segment as line segment AB. This one as line segment AB. Okay, and we will represent this line segment with AB. On that AB we have to keep that one of that line. Okay, is it clear? So here what are the properties of that line segment? So the first property is a line segment has how many endpoints? That is the first point. How many endpoints it has? It has 2 endpoints. So a line segment has 2 endpoints. Next thing, is it possible to measure that line segment length? Is it possible? Yes, obviously it is possible. Why? Because here we have that 2 endpoints. Okay, wherever I am standing, for example, in front of me any object is there. So can I calculate the measurement in between? Can I calculate the distance between me and that object? Yes, that is possible. Why? Because here one of the object is there and this is my position. In between, what is the length? By using any instrument, by using either that is a tape or that is a scale, okay, whatever it may be, I can use that objects and I can measure that length. Right? So like that only, for example, this is that my position and this is that object position. Okay, is it possible to measure the length between those two? Yes, obviously. So here this is a finite measurement or infinite measurement. Here exactly those two are having that a fixed places. Here the fixed point of A and this is the fixed point of B. I fixed those 2 points. So there is no chance to increase that length. For example, here I measured this one. This is a 5 centimeters something I got it. Okay, or 5 meters. I fixed those 2 points. Is it possible to increase the length here? Not possible. Why? Because those two are fixed points here. Okay, that's why we are calling those two are end points. Okay, so here length is a finite or infinite. This is having a finite length. So line segment is having that a finite length. Okay, why? Because we can measure. If we cannot measure the length, then that is having that infinite length. Okay. Afterwards, is this having a length? Yes, just now only we discussed. Is this having a breadth? No. Is this having a thickness? No thickness. So line segment is not having that no thickness. Is this having a thickness? Line segment is not having that any thickness, or that is not having any breadth. Not having a thickness and no breadth. So these are that properties related to line segment. Okay. After that line segment, we have that ray. Okay. Why? Because after that we are taking that ray means ray is also, if you extend that one of that, if you extend one of the side, okay, one of the side of line segment, then we will get that ray. Okay. Let us see about that ray. So here what we discussed, if I extended one of the side or in any direction, okay, either that is right side or left side of that line segment. Okay, now we will got one of the figure now here, that is known as a ray. Okay, so what is the definition for ray here? A line segment which can be extended endlessly in one direction. A line segment which can be extended only in one direction, then we will call that one as ray. Okay, so how we will represent this one? Here ray representation is ray AB. On that AB we have to keep like this. Okay, here arrow mark shows that it can be extended. Here full stop is there. Full stop means the point shows that that is that ending point. Wherever you have that arrow mark is there means it can be extended endlessly. Okay, it doesn't have that any fixed point, or it doesn't have that any exact constant point is not there here. Okay, that's why it can be extended. Okay, for example, here I am standing, in front of me one bus is there, that is also going in this direction only, in the same direction. Here my point is a fixed point. If that is in moving direction, I can't say that up to which point it will reach. Exactly, I can't say that, right? So it is in moving position. So in between that bus and me, that distance is increasing or decreasing. We both also there in that same direction. So the distance is increasing. Right? So exactly I can't say that what is that exact end point of that bus, exactly where it will reach. I can't say that, right? So in the same way here AB means one of the direction, it is in continuously, we can say that extended endlessly in one of the direction. Okay. So another one of that example, if you take that sun rays. One of the example is sun rays. Here we have that sun. Okay, rays will fall on that. Rays falls like this only, no, on that earth. Okay, for example, in between we have that any surface is there. So sun rays falls on this surface. Through that surface here, sun rays falls on that earth also, no. So for example, you not only earth, if you take that some other spheres also there, exosphere, stratosphere, in science we can learn those, no. So sun rays falls on that surfaces, through that surfaces again it is falls on that some earth. Okay, if you keep something here, some hole, if you dig here some of the hole, then that the rays falls inside of that hole also, no. So that doesn't have that any end point here, but here this is having one of the point, that is the starting point. Here sun is that fixed point. Okay, so here this is having that, this is that starting point as well as that is initial point, but this is not having here any other end points. Okay, that's why we are saying here ray is having only one end point. Ray is having only one end point. If you take that another example, that is a torchlight. If you take that one of the torchlight here, if you switch on that torchlight, actually this is that starting point or initial point of the torch. If you switch on that, then the rays passes like this only, no. Okay, so I kept here one of the surface. I kept here one of the surface, or that is one of the wall. Okay, so these light rays falls on that wall only, no, here. So this is here, up to here I kept one of the object. If I remove that object, here I kept, then this rays falls on that wall or not? Obviously. Okay, or else here I kept one of the paper. Through that paper also some rays will passes through that paper and it reaches to that next surface. No. Okay, but here back side of that torch, here we can't see that any rays. Okay, this is the starting point. Through that starting point only we have that some rays. Is it clear? No? So that's why here this is that starting point, but here another end point is not there. That's why we are saying that starting point only we will consider it as end point. So that end point is known as initial point or starting point. Initial point or starting point. So what are the examples for rays here? One of that is sun rays, another one is torchlight. Okay, these two are the examples for that rays. So what are the properties? So the first property is already we discussed that is a ray is having only one end point. Yes, that is having only one end point. Come to that second property. What is that? Here is this having a finite length or infinite length? Yes, this is having infinite length. Why? Because by observing this figure only we can say that here this is a fixed point. Here I fixed the torchlight, but I am not fixing these surfaces. Okay, I am changing the surface places. I am changing here. Okay, so that's why here to here this is having, for example, 5 centimeters or 5 meters. 5 meters length is there. If I changed the position of the surface, I kept here. Now the length is increased or decreased, or if I kept here, then the length is decreased. So whatever it may be, the changes happening are not here. So changes are happening, no, by that is depends on that surface, but I fixed that torchlight position. Okay, so that is having one of that end point, but another end point, that surfaces I am not keeping exactly at somewhere. Okay, that's why here this is having infinite length. So a ray is having infinite length. So infinite length means we can measure that exact length? No, we cannot measure that the exact length of a ray. Okay, that's why here this ray represented, one of the side we can represent with a full stop, which means that is a dot or point. One of the side we can represent with a point, another one is arrow mark. Okay, arrow mark shows that it can be extended endlessly. Okay.